All right, welcome back, everybody. This is part 2 or 9.2 of our hypothesis testing. In part 1, we talked about the different components of hypothesis testing, just kind of what they were, a couple of examples of how to find them, but we really didn't put everything all together. And the reason the summary of the steps is up is because this was the last thing that I left you with from 9.1, and we're going to utilize these 5 steps to do a couple of different problems with hypothesis testing. All right. So you may have a desire to skip steps, leave out steps, just do some steps in your head. I'm definitely going to encourage you not to. All right. Doing all 5 of these steps is going to allow you to get more problems correct in your class. And if something were to go wrong, the act of writing out each one of these is going to potentially give you more partial credit if something were to go wrong. All right, so definitely take a moment. If you haven't written these down already, please write them down. And then when you're ready, start up the video again, and we'll continue from here. All right. So let's continue from here. All right. So in this section, we're going to focus on the Z test for the mean. All right. And now let's remember our Z formula. It is X bar minus mu over our standard deviation, or in the case of our central limit theorem, all right, standard divided by the square root of our sample size. In other sections, we're going to use other distributions, but for right now, this will focus solely on utilizing Z. All right, as promised, let's just jump into some examples. All right, so the first example, a researcher reports that the average salary of assistant professors is more than $42,000 per year. A sample of 30 assistant professors has a mean salary of $43,260. At alpha equals 0.05, test the claim that assistant professors earn more than $42,000 per year. Standard deviation for the population is 5,230. All right, so, all right, take a moment to write it down, pause the video if you need to, and we'll continue in just a second. All right, hopefully you paused the video and did that. So I'm going to utilize the steps that we had in the beginning, and I'm going to literally number them to kind of show you that they do have a logical flow. So the first thing I need to know is, what is my null hypothesis? What is my alternative hypothesis? Now, remember, the null hypothesis means nothing changes, right? And the research report says the average salary is $42,000. So I'm going to say that mu is less than or equal to 42,000. Now I said dollars. Now I said less than or equal to because we have a sample that says that the salary is more, right? So my alternative is that the average is greater than $42,000 per year. All right, and this is my claim. How do I know it's my claim? Because in the problem it says at 0.05, test the claim that assistant professors earn more than $42,000 per year. So wherever I put the earn more than $42,000 per year has got to be the claim. Remember, for my null hypothesis, I always want this equals part there. All right, that's going to really be helpful. All right, so number 2, we want our critical value. All right, so our alpha equals 0.05, and it's a right tail test. So we can draw a very quick picture. So right tails over here, there's 0.05, and this is 0.95. So I want you to go to your Z table and find that value. So pause the video, go there, and we'll talk about it on the other side. All right. So the value you should have gotten was 1.65. And now we need to compute our test value. All right. So our test value is going to be gotten by our Z equals, right, our X bar minus mu over our standard deviation divided by our sample size. So our X bar was 43,260. We're going to subtract that from the established average, right? If we look up here, we say the report says the average is 42,000. Our sample is 43,260. So that's where I'm getting those numbers from. I'm going to divide that by my standard deviation, which is 5,230, divided by the square root of our sample size, which is 30. So at this point, why don't you pause the video, do the calculation, and let's see what the test value is. All right, so hopefully you got your test value. I got the value to be 1.32. All right, so now we have a decision to make. Do we reject or not reject? And from here, I'm going to redraw the picture I had. And 1.32 would be a little bit less than that, so 1.32. Now remember, this is our rejection region. So 1.32 falls outside the rejection region, so we do not reject our null hypothesis. All right, so if we do not reject the null hypothesis, there is not enough evidence to support the claim, because we're not rejecting it. Doesn't mean we're accepting it, it just means we're not rejecting it. All right, so I often like to summarize the results. There is not enough evidence to support the claim that assistant professors earn more than $42,000 per year. All right. So remember, the wording needs to be very precise. There is not enough evidence to support the claim. All right. Let's go on to the next example. All right. A researcher claims that the average cost of men's athletic shoes is less than $80. He selects a random sample of 36 pairs of shoes and finds the following costs. Is there enough evidence to support the claim at alpha equals 1/10? All right, and below, we now have listed 36 pairs of shoes and the prices. So, the first thing we need to do is we are going to get our null and alternative hypothesis. If you still need to write this down, pause the video and come back in just a second. All right, hopefully you pause the video and we're able to write this down. So let us get our null and alternative hypothesis and try to identify our claim. All right, so in our problem, I'm going to highlight this. The researcher claims the average cost is less than $80. And we need to know if there's enough evidence to support the claim, which means that I'd really like my claim to be my alternative hypothesis. Because if we reject the null, we support the claim. So we can only support something indirectly. So I'm going to say mu is less than, make it better, less than $80. And the opposite of that would be that mu is either greater than or equal to $80. Again, the null always has the equal to part of it. Second step, I need my critical value. Now my critical value, I have my alpha equals 0.10, and it's left-tailed. So I'm going to make a quick small picture. And in my left tail, I'm going to have 0.10. That's my rejection region. So I'm going to look up that area on my chart. So why don't you look up that area on your chart, and we'll talk about it in just a second. All right, hopefully you looked up that area. I got negative 1.28, and there is my border between my rejection and my non-rejection region. All right, so now the third step is we need our test value. And this is where all that data comes into play. First thing I need is I need X bar, and I need my S, my standard deviation for my sample. So I'm going to scroll back up. I'm going to show you that data. I'm going to ask you to pause the video for just a second and calculate X bar and S. All right, hopefully you paused the video and calculated X bar and S. So I got X bar to be 75 and S to be 19.2. All right. And now I got to compute my test value. So I got 75 minus 80 over 19.2 divided by the square root of 36. So why don't you pause the video now once again, and let's see what number comes out. All right. Hopefully you got the same number I did. I got negative 1.56. All right, so now we have to start making some decisions. The way we make decisions is I'm going to make a slightly larger chart, or a larger, picture. I'm going to have my border at negative 1.28. But I notice that my test value comes in inside my rejection region, right? So our decision is going to be to reject the null hypothesis. And if we reject the null, that means we have enough evidence to support our claim. And that's what I'm going to say in my summary. There is enough evidence to support the claim that the average cost of athletic shoes is less than $80. All right, so we had one where we rejected, we had one where we did not reject. All right, let's try one more example and see how we do. So, the Medical Rehabilitation Education Foundation reports that the average cost of rehab for stroke victims is $24,672. To see if the average cost of rehabilitation is different at a particular hospital, a researcher selected 35 stroke victims and found the cost to be $25,226. The standard deviation for the population is $3,251. At alpha equals 0.01, can it be concluded that the average cost is different from $24,672? Now, before we start this problem, I want to take notice. Let's scroll back a little bit. In this problem, right, the researcher claimed the average of men's was less than $80. And if it was less than $80, we had a left-tailed test. In the first problem, we had a researcher looking to see if the salaries were more than, and we had a right-tailed test. Now I'm going to go back to the problem that we are currently in. All right? And I'm going to highlight what makes this problem different. At 0.01, can it be concluded that the average cost is different from? Okay, I'm not stating that we're hoping to prove it's more than or less than. We're just saying different from. Now, that's going to affect our null and alternative hypotheses. So we need to figure out what our null and alternative hypotheses are. Well, the null is everything's the same, that the average is $24,672. And the alternative says it's different from. Well, different from would be null is, or the average is not equal to $24,672. And this would be our claim. All right. Now we're going to see what happens if we just say not equal to. All right. So the next thing we need is our critical value. And our critical value, we need our alpha, which is 0.01. And now because we just have not equal to, we have a two-tailed test. And I'm going to quickly draw what I'm referencing on our two-tailed test. So we have one tail here, one tail here. Both of these would be considered rejection regions. All right, so what happens is that alpha gets divided by 2 because we put half of our area in one of the rejection regions and half of our area in the other one. All right, so which would be 0.005, and this is, right, 99 all the way back. So we're looking for area of 0.995. So let's look up that area. And let's get both, I'm going to erase this so I can put both of our values right on our picture. I got values of 2.58, negative 2.58. If you wanted to look up the negative 2.58, you would simply look up that area on your Z chart. All right, so the next thing we're going to do is compute our test value. So our test value is going to be computed by our Z formula. So Z equals, and our X bar was $25,226. Subtract that from what we think is the established average, which is 24,672. We'll divide that by 3,251, square root of our sample size, which is 35. So why don't you pause the video and let's see what this value is. All right, hopefully you paused the video, did the calculation. I got 1.01. Excuse me. Now it's time to start making some decisions. So I'm going to make a slightly bigger picture. And again, I definitely endorse making this picture to make your decision. So this is 2.58, negative 2.58. And over here we have 1.01. Looks to me like it falls outside the rejection region. So our decision is to not reject our null hypothesis. And again, if we are not going to reject our null hypothesis, right, our summary is going to say there is not enough evidence to support the claim that the average cost is different from $42,672. It could be, but the evidence we've gathered doesn't give us enough. All right, so the last thing I want to talk about is I want to quickly talk about the p-value test. I mentioned it in the last video. We didn't really talk about it. It's kind of appropriate to do it now. So p-values deal with area instead of z. So for example, you compare your p-value to your alpha. So I think it's best illustrated with an example. All right, now I'm going to say up front, depending on the example, you could either use the traditional method, which is what I've been doing up until now, or you can use p-value. Now, some of the problems are going to say, use the p-value method. If it says use the p-value method, you got to use p-value. If it doesn't say that, really either test could be used to see. All right? So hang on for the example. All right, so a researcher claims wind speed in a certain city is 8 miles per hour. A sample of 32 days has an average wind speed of 8.2 miles per hour. At S, meaning our standard deviation of the sample, is 0.6 miles per hour. At alpha equals 0.05, is there enough evidence to reject the claim? Use the p-value method. All right, so the p-value method starts very similar to what we've been doing up until now. All right, the first thing I want to do is figure out what my null and alternative hypotheses are and where my claim is. So my null is that mu equals 8. My alternative is simple, that mu doesn't equal 8. Right? And we look back at the problem. Problem says pretty explicitly, a researcher claims wind speed is 8 miles an hour. Therefore, my null hypothesis is the claim. All right, so the next thing we're going to get is our test value. All right, and our test value is going to be z equals, and I'm going to use my z-score formula, 8.2 minus 8 over 0.6 divided by the square root of 32. I'm going to ask you to quickly pause the video and get the value and come on back. All right, hopefully you paused the video and got the value of 1.89 because that's what I got. So far, we're doing things fairly similar to the traditional method, right? Here's where we break. Third step, we're going to find the p-value. Now, to find the p-value, we're going to take that 1.89 and we're going to look up the area on the z table. Now, let's make a quick sketch. All right, if I want to get area to the left, right, that means I'm looking up 1.89 over here, right? But remember, I have a two-tailed test here, all right? But I'm getting the area all the way to the right, or all the way to the left, excuse me. I just want the area in there and in there. So what am I going to do? I'm going to find that the area of 1.89 is 0.9706, and I'm going to say 1 minus that to get my area to the right. And I get that area as 0.0294. So I'm going to take my alpha and I'm going to split it in half. So my and then I'm going to realize that if I get my p-value area of 0.0294, that is going to take me out here, outside my rejection region. All right. So, and this is on both tails, by the way. So, right. This takes it outside my rejection region. So that's 0.0294. There we go. All right. Another way to do this is to say, because it's two-tailed, if I take that area and multiply it times 2, which I basically did in my picture, I get a value that is not equal to, but greater than my alpha, greater than 0.05. And if that is true, it is outside my rejection region. So now we have two ways of finding it. So we do not reject the null. And if we do not reject the null, we can say in our summary, there is not enough evidence to reject the claim Remember, our claim was our null hypothesis. So if we do not reject the null, there's not enough evidence to reject the claim that the average wind speed is 8 miles per hour. All right, so again, the p-value test changes things slightly. Instead of looking at where we fall on our axes, we're simply looking at area. And if our p-value covers more area than our alpha does, that's when we reject the claim. If our p-value covers less area than our alpha does, then we do not reject. And then we can reject the null hypothesis. All right. Thank you for listening, and I look forward to seeing you next time.